All right, here's an example of the mean value theorem. Casey thought we should do a couple extra examples of these, so here's one I just made up. Let's say I've got this function 2x minus 2 over x plus 2. So it's going to have a vertical asymptote at negative 2, so that's what this is, at negative 2. And it has a horizontal asymptote at positive 2, right? So this is y equals 2, the horizontal asymptote. So you know, you can look at a rational function, you should be able to figure that out. Other things, so what else is going on here? Well, we've got to find 2 points, find the slope between those 2 points, and then the mean value theorem will say if the function's continuous and if the derivative is defined between those 2 points, that there'll be a point between the two where the first derivative, that is the slope of the tangent line, will equal the slope between the 2 points. So let's find a couple of points to start with, and then we'll see, you know, what if we can find the slope of the tangent line. So I think it's easy if you find f of negative 1. F of negative 1, if we put negative 1 in here, is going to be negative 4, I think, over positive 1. So that's going to be negative 4. So here at negative 1, it's going to be 1, 2, 3, 4 down here. And then if we put in maybe positive 4, f of 4 is going to equal 8 minus 2 over 4 plus 2. And that's going to be 6 over 6, so that'll just be 1. So here at positive 4, 1, 2, 3, 4, it's going to be 1. So our curve goes something between there, and you know from the asymptotes that it's, you know, it's probably going to go like this. Well, let's find one other point here. Let's find the y-intercept and the x-intercept. If you put x equal to 0, you can see that the y-intercept is going to be negative 1. So f of 0 is going to be negative 2 over positive 2, which would be negative 1. So we also know it's going to hit the y-axis right here. And then where it's going to hit the x-axis, what's going to make the numerator equal to 0? Remember, to get the x-intercept, you just have to make the numerator of a fraction equal to 0. So if we just put a 1 in there, we'll get the x-intercept, I think, where f of x equals 0. And that's going to be where 2x minus 2 equals 0. So x would just equal 1. So there's another point we have. So we got a bunch of points here, so the curve looks like it goes like this. What we're interested in, of course, is we want to know between these 2 points, what's the slope between this point and this point. So the slope there, m, is going to equal f, and this of course is positive 4 and this is negative 1. So we're going to take f of 4 minus f of negative 1 over 4 minus negative 1. F of 4 we know is 1, and f of negative 1 we saw was negative 4, and 4 minus 1 is going to be 5. 1 minus negative 4 is going to be 5. So the slope here is going to be 1. So this slope between this point and this point is 1. So what the mean value theorem says is we should be able to find another point somewhere along this curve where the first derivative, and remember that's the slope of the tangent line, is also equal to 1. So where f prime equals 1. So that's what we're looking for. We're looking for that point right there, the x-coordinate, that'll give us a first derivative equal to positive 1. That's what the mean value theorem says, okay? So we take the first derivative. Let's take the first derivative of this thing. So let's say this is f, and let's say this is g. And if we do that, then f prime is going to be just 2, and g prime is going to be 1. And then we can use the quotient rule. So f prime is going to be low, x plus 2, times the derivative of the high function, so that's times 2, minus the high function, 2x minus 2, times the derivative of the low function, which is just 1, and that's all divided by the low function squared. Alright? So we simplify that. Let's distribute here. So we end up with 2x plus 4 minus 2x plus 2 all over x plus 2 quantity squared. The 2x's cancel. So we end up with just 6 over x plus 2 quantity squared. So that's f prime. And what we do for the mean value theorem, we take that f prime and we make it equal to the slope between the 2 points that we're interested in. So we know the slope here is 1. So m equals 1 of this line right here. So we just make the slope, or the first derivative, equal to that slope. So we make that equal to 1. I'm going to cross multiply here, so bring this to the other side, bring the 1 over here, so I get this. 6 equals x plus 2 quantity squared over 1. And then I take the square root of both sides, and I get square root of 6 equals x plus 2. And you might have to consider a negative square root of 6, but I don't think in this case we're going to do that. And then I'm going to bring the 2 over here, so this is going to be root 6 minus 2 will equal x. Okay? So what is that point? Well, let's see on our calculator, root 6, and then minus 2. Put that number in memory is 4495 about. So this is approximately 0.4495. So what that tells us is this little number right here, you know, the x-coordinate of this point is 0.4495. So x equals 4495. And we want to verify that that really does make the first derivative equal to 1. So we take it and we put it back in here for x. Right, we put it right in there. This is our first derivative. So we put the x-coordinate into the first derivative to see if the derivative really is 1, if the slope of the tangent line really is 1. So I've got that in memory in my calculator, so I can just do that. If I go plus 2, take that answer, plus 2, and then square it, I get 6, and 6 divided by 6 is going to be 1. So that turns out to be the slope of the tangent line at that point, 0.4495 is 1. And that's what the mean value theorem says we have to be able to find. We have to be able to find that x point, or there exists an x point that will give us that same slope. Okay?